Hello everyone, welcome to today's class. We are continuing our class on surd, and today we are going to deal with multiplication and division. Now, this is a rule for multiplication. When two or more surds are multiplied together, they should first be simplified if possible. If possible means if it can be simplified. If it's not, leave it that way. Then multiply whole number with whole number and surds with surds. So let's start the class. So let's start. They said when two or more numbers are multiplied in surd, first you have to simplify, then multiply whole number by whole number and surds by surd. So let's start. The first thing we are told to do is to what? Simplify. So 27 multiplied by 50. Now we've done this thing so many times, so no need for this. 27 is the same as 9 times 3, or multiplied by 50 is the same thing as 25 times 2. Now, so this is equal to square root of 9 multiplied by square root of 3 for this part. Then let me put it in parentheses, or multiplied by square root of 25 multiplied by square root of 2. So this is the same thing as square root of 9 is 3, so this is 3 root 3 multiplied by square root of 25 is 5, that is 5 root 2. Now the second rule says multiply the whole number by whole number and the surd by surd. So it means it will be 3 times 5, or multiplied by 3 times 2. Hope you get it. So whatever that is inside the surds will multiply themselves inside the surd, while the ones that are outside multiply themselves outside. That's what they mean by that statement. So the final answer is 15 times 3 times 2 is 6. 3 times 5 is 15. So this one is 6. So the final answer is 15 root 6. Now take note, we are stopping at 15 root 6 because 6 cannot be simplified further. There are some cases where after the multiplication, you notice that you can still simplify this. In that case, you continue, but at this point, this is the last rational root, irrational surd, so that's where you're going to stop. So let's look at another example. So this is another example, example 2. We have root 12 multiplied by 3 root 60 multiplied by 45, that's root 45. So let's start by simplifying. 12 is the same thing as 4 times 3, 4 multiplied by 3 root 60 is the same thing as I think is 15 times 4. Is there any other simplification, any other perfect square that can be made out of this? I think is if I'm not wrong, is 15 times 4. So we can just check it out. 4 times 15, that's what will give us 60. So times 45 is the same thing as 9 times 5. So let's start. This is equal to root 4 times root 3 multiplied by 3 times root 4 times root 15, or multiplied by root 9 times root 5. So now this is equal to root 4 is what? 2 root 3 times 3 times root 4 is also 2 times root 15, all multiplied by root 9 is 3. So this is 3 root 5. So we are still going. Let's continue. So this, I hope you are seeing it. This, I'm moving it to this next page. So it will give me two. Okay, let me write it out for those of us that might find it confusing to follow up. I'm writing it exactly what we have there. So what we have from the other pages, this. Three root 5. So this is equal to, now we'll continue our simplification. 2 root 3 times 3 times 2 is 6. So this is 6 root 15 times 3 root 15. Remember the rule, multiply the whole number and multiply the surds. So it will be 2 times 6 times 3, or times 3 times 15 times 15. So 2 times 6 is what? 12. 12 times 3 is 36. So you have 36 all times. Now there is something I want you to observe here. This is 15 times 15. That means it's a perfect, anything we get here will be a perfect square. Instead of us to go and solve it, okay, but in order to avoid confusion, I can also say 3 times 15 times 15. What's the answer for 15 times 15? Okay, sorry, I think I made a mistake here. That some of you would have observed that mistake. This is actually 5, not 15. So sorry for that mistake. So what I have here is 5. Forgive me for that. So here too is 5. So not 15. Some days are like, I know some of you observed it, and for those observed, we are such a great student. So now we have 3 times 5. 3 times 5 is what? 15. 15 times, so 3 times 5 is 15. So I'm supposed to have 3 times 5 times 15. So the mistake has been done. So let's continue that way. 36 multiplied by 3 times 5 is 15. So it will be 15 times 15. Now 15 times 15 is already a perfect square. Whatever answer we get from it is a perfect square. So I can just solve it here. 15, 15. 5 multiplied by 5, 5, take 2. 5 times here is 5 plus 2. That's 75. 1, 1, 1, 1. So your answer is 225. So this will give us 225. But the point I'm trying to make here that this is already a perfect square. You might not, for those that want to jump step, you don't need to, you might not necessarily multiply it out. You can just from here and know that whatever we get here is 15. But for those that still want to follow the full step, it will give us 36 times square root of 225, which is the same thing as 36 times 15. So whatever we get from this is our final answer. So let's solve it. 36, 15. 5 multiply 30, write down 0, take 3. 5 times here, 15 plus 3, that's 18. 1 times 6, 1 times 3. So this is 14. Take 1 here, and this is 5. So your final answer is 540. So sometimes you can solve for surds, and at the end of the day, you get an answer that is not surd. So it's possible. So let's have that in mind. So let's go to the next example. So this is the next example. 2 root 5 all bracket raised to power 2. What does a number raised to power 2 means? Anytime you see a number raised to power 2, it means multiply that number by itself. So this is the same thing as 2 root 5 multiplied by 2 root 5. That's what it means. So in this case, we still use our, it's already simplified. There's nothing to simplify here. So just go straight to our rule. 2 times 2 times 5 times 5. For those of us that want to jump step, 5 times 5 is already a perfect square, meaning that whatever we get here will give us 5. But for those that want to continue, it will just be 2 times 2 is 4 root 25, which is the same thing as 4 times first root of 25 is already 5, which is the same thing as 20. One thing about surd is that since surd is a square root of a number, whenever you square surd number, you are most likely to get a whole number. So there is this example I want to just touch, just like trying to be, I will just show you when we start solving it. So look at this example. We have this whole long surd to multiply out, and we all know that according to our rule, whole number and surd, now there is no whole number, so everything is inside the surd. So we are going to have something like a long surd like this. We have 2 times 3 times 5 times 12 times 45 times 50. This is equal to this. Now, if you know your perfect square properly, there's a shortcut you can go about this. You can just say something like, now we all know that 2 times 50 is 100, and 100 is a perfect square. So I'll still keep all of them inside the sort. So now with 2 times 50. So I've taken this out, I'm taking this out. So the next one we can go about is, we all know that 3 times 12 is 36, and 36 is a perfect square. So I have 3 times 12. So I've taken this out, I've taken this out, so I'm left with these two. Now 5 times 45, even if it's not a perfect square, that's what we are left with. But 5 times 45 is 225, which is also a perfect square for what we did in the previous example. So I have 5 times 45. But you can only use this method if you know your perfect square and your multiplication properly. If you don't know them, just use the normal simplification method I taught you. Use your factorization method to factor out the numbers and know the perfect squares, then simplify further. So here now, you have something like this. You have something like this is 100 times 36 times 225. Now we also bring it out, square root of 100 times square root of 36 times square root of 225. Square root of 100 is 10 times square root of 36 is 6 times square root of 225 is 15. So these, just if you know your how to play with your multiplication, you can make this easy. Instead of multiplying this out, start looking for the perfect square and then factorizing it further. You see the way we jumped step. I will solve this if we didn't use this method again. So you see the difference. So here now we have 6 times 15 is 90. 90 times 10 is 900. So this is your answer. So let me solve this example again without using this method. So you see the long process we would have gone if we didn't go through this process. But I'm also solving it for the benefit of those that might not know how to play with these numbers here, so they can continue without confusing themselves. So we have something like this is a question, root 2 times root 3. Oh, my hand is not covering you. Oh god, this making some mistakes. Times root 5 times root 12 times root 45 times root 50, which I said is equal to 2 times 3 times 5 times 12 times 45 times 50. Now for the benefit of this class, let's use calculator to punch this figure. So when we punch it through the calculator, we are getting something like 81000. You see the whole stress we have to go through. And if we are to factorize this, one thing I know for sure is the fact that we have 4 zeros here means this is equal to Though this is because I have the knowledge. If you don't have the knowledge, it's just for you to find the two perfect squares that are inside this figure. I know this is equal to 81 times, that's 10,000, because this gives us this. I already know. I know some of you might not get it, but there is other ways you can also get other perfect squares. Let me say something like, because I know that this 10,000 is a perfect square and this 81 is a perfect square, because this is 9. This is 9 times 9 gives 81, and 100 times 100 gives this. So if you are to solve it, you are still getting the same 900 that we get before. But let's see if the long factorization method will help. Let's just try and see if it can actually help in this case. The but the thing is, even if you want to use this long factorization method, we are going to end up with a perfect square, because this is a perfect square. You understand? For those of us that weren't in the class when I teach how to get a perfect square, you start with the smallest amount of number. By the time you divide it by 2, have to find the square root of a number. Here I'm going to have 4. Here I'm going to have 5. And no, this is for 0, because 2 divided by 1 cannot go 0, so I take it here. I'll have 5, 0, 0, 0. So by the time I'll keep dividing this all through, what will happen is that it will factorize completely. Then you now take it 2 step by 2 step. For those that were not in this class, when I taught about how to find the square root of a number, you can check our previous class, and I'll try and know if I can put it on the description below for you to go through them. So by the time you keep dividing, what will happen is that this will factorize out. Okay, let's just show it. I know it's going to be a long class, but okay. Then you go divide by 2. 2 divided by here, you have 2. 2 divided by here again, you still have 0. 2 divided by here, have 2. Take 1 here, 5. 2 divided 0, 0. 2 again, 1, 0, 1. 2, take here and 5, 0. 2 divide again, we have 5, 0, 6, 2, and 5. 2 go here, 2, take 1 here, 5, 3, 1. Oh, sorry, 2 cannot go. So that was a mistake. So from here, the lowest number I think that can go here is 5. So I'll put 5 here. 5 go here, 1. 5 go here, 0. 5 go here, 1. Take 1. 5 go here, 2. 5 go here, 5. Next is 5. 5 go here, 2. 5 go here, 0. 5 go here, 2. 5 go here, 5. Next again is 5. Hope you can see it. 5 go here, 4, 0, 5. Next again is 5. Sorry, I put 2 here. This is 5. This is 5. 5 go here, 8, 1. So I think for me to using 5 ahead of 3, because the next smallest number here now is 3, means there was already a mistake, but I hope you are still following. Let's continue for the sake of this class. 3 go here, we have 9. We have 27, sorry. 3 go here, we have 9. 3 go here, we have 3. 3 go here, we have 1. See, it factorizes out. And for you to find the square root, you take it 2 by 2. So this 2 will give us only 2. 2 number of the same number, 2. So this is 5. 5. I've taken this one. This is 5. 5. This is 3. 3. This is 3. 3. So the square root of 1, 8, 1, 0, 0, 0, 0 will give us 2 times 2 times 5 times 5 times 3 times 3. By the time you multiply all these things out, 2 times 2 is 4. 4 times 5 is 20. 20 times 5 is that's 100. 100 times 3 is 300. 300 times 3 is 900. So you're still getting the same 900. So this is just me trying to tell you how to find the square root of a number using the factorization method. So let's go back to what we are solving. So now when I did this, we have square root of 81 times square root of 10,000, which should give us 9 times 100, which is giving us the same 900. So the reason why I have to go through the stress of solving this after solving it in this rearrangement method is for those that might not know how to come up with how to arrange a number to get a perfect square. You can still solve it the normal way we know how to do it and get your answer correct. So this is all about multiplication of surd. So I'm going to take one example from the exercise, and that will be that for this class. So exercise 1E number 7 is what I want to solve, and the question that was asked there is surd 2 raised to power 3. This is the only one I want to solve from the exercise because the examples we did touched it thoroughly, so there's no much need to solve the exercise. So now, what does raised to power 3 mean? It means the number multiply itself 3 times. So this is equal to square root of 2 multiplied by square root of 2 multiplied by square root of 2 again. So this is the same thing as 2 times 2 times 2, which is the same thing as 2 times 2 is 4. So we can leave it at 4 times 2 since 4 is a perfect square. So that will give us square root of 4 times square root of 2. Square root of 4 is 2, so it will be 2 root 2. That's our final answer. So that's it for this class. Thank you and see you in the next class.